Oh, hey, didn't see you there. I was just thinking about what we learned in physics today. You might be asking, what is that, Connor? And I have the answer for you right now. Have you ever wondered, why does a car sound different when it's passing you and then sound different after it passes you? I was wondering the same thing until after Miss Ekman taught me. It's called the Doppler effect. See, let's say an ambulance is passing you. You hear really loud, wow, really loud. Then it passes you and then it goes and slowly fades away. Gets really high when it's coming towards you and really low as it passes you, and that's just the sound waves acting in a different way, elongating, so that's called the Doppler effect. We're going to show you how that works as we step out right to the car.
The Doppler effect is an occurrence in which sound waves essentially sound different when in different locations relative to the source of the sound. So in this picture, the source of the sound being the ambulance, and the two people relative to the ambulance being this guy and this guy. So what happens is, as the sound source gets further away from you, the wavelengths become much longer, making it a lower frequency. So as you can see here, these wavelengths slowly get farther apart, making it a lower frequency, and which will make it sound much different from what this guy would hear, because the wavelengths are super short, making it a higher frequency.
So, I was baffled the other day.
By what?
Well, I heard this noise in my house, and I couldn't tell where it was coming from. It seemed like it was louder in some areas when I stood there, and quieter in other areas, and I just could not figure out why.
What the heck? That sounds really weird.
Yeah, and I thought it must have to do with something, the physics behind how waves work, probably, because I remember my physics teacher saying something about that, but I'm not really sure.
Huh. I think I actually know what you're talking about.
Really? What is it?
Yeah, it's like constructive and destructive waves. So they interfere in certain ways so that it seems louder and quieter in different places.
Interessante. Is there a experiment we could do to demonstrate this?
Yeah, we could fill up a little container of water and then use two identical fingers to demonstrate how the waves either constructively or destructively interfere.
Yeah, that's a good idea. Let's do it.
Let's give it a rip.
We're gonna do that now. Let's use this bucket right here.
Oh, that is ideal. Use these two fingers right here.
Those ones. Fill this puppy up with water for a while. And then we'll do it. I will now explain the phenomenon of wave interference. Wave interference is a phenomenon that occurs when two waves meet while traveling along the same medium. The interference of waves causes the medium to take on a shape that results from the effect of two individual waves upon the particles of the medium. Constructive interference is a type of interference that occurs at any location along the medium where the two interfering waves have a displacement in the same direction. Destructive interference is a type of interference that occurs at any location along the medium where two interfering waves have a displacement in the opposite direction. In this slow-mo video, you will see the examples of constructive and destructive waves.
Okay.